All right, so this is the second half of 8.2. And again, this one should be the evaluating function. So we call this 8.2 part 2. Okay, so domain and range, you're looking left and right. So you find the farthest most point to the left, which would be this point right here. And basically you can go back and kind of go ordered pairs right here. This point would be at 1, 2, 3, 4, 5. So that's at -5. This is up 1, 2, 3, 4. Okay, go the farthest point on the right, which would be this point. It's at 1, 2, 3, 4, 5, 6. Also at 4. Okay, so take the left-hand point, take the right-hand point. And if they ask you for the domain, tell me the left-hand value, which is -5. Tell me the right-hand value, which is 6. And that should be the two numbers you're looking for. Now, and they should ask you to write the answers in interval notation. So if they do, then that would be the answers here. Now, the one thing I was going to check and see, but the system is down on Alex, is if these were solid circles, those should have been solid brackets. Sorry. Oh, just found out what this ordered pair was. So this was over 1, 2, 3, 4, 5, 6, and this was at 4. Just kind of matching up where this would have been right here. Oh, so when you're talking about the domain, remember, domain is just your x values.
Okay, that's right. Okay.
So when you're talking about the domain on this one, you don't even care about the y values. Now, the only reason we did the y values with this part was when we talk about the range, now you're looking at the y values. But now, remember, when you're looking at the y values, you're looking for the highest point on the graph and the lowest point on the graph. So when you're talking about domain, because it's x value, because this is the x-axis, you have to look left and right. When you're talking about the range, this is when you have to look up and down. So if you go up, what's the highest point on the up part up here? Well, it's a tie, right? Yeah, because it's either at -5, 4 or 6, 4, but your highest point is at 4. And then if you go to your lowest point, that's right about here, looks like. If we check that point, that's at 1, 2, 3, -4. So your low point is at -4, your high point's at 4. So that should go from -4 to 4. Because this point would be at 1, -4. Your high point up here would have been either, it's a tie, so you take either one, but you're still only looking at the y values. Okay, so that's the biggest thing on those with the graphs, is just make sure that when you talk about the domain, you find the leftmost point on the graph, you find the rightmost point on the graph, and you only look at the x values. So, when you're doing the domain, you just worry about the x values. When you're doing the range, you find the high point, which may or may not be 1 point. In this case, it was 2 points. And you find the low point, and then you tell me the y values at those 2 points. And that's where you have to kind of separate the two when you're going through that. They'll give you, I think this is another one of those things where they'll give you like boxes and you go back and fill them in and just pick out the different numbers. But that's really the one thing. If they give you just a straight line, let's do one here where we've got an open circle here and a solid circle here. So let's say this point was at 1. Okay, so we had something like this. And again, biggest thing is I'll go back and give you the points here. This is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this ordered pair would be at 10, 1, 2, 3. Whoops. Sorry, I got messed up here. Okay, so that's at 1, 2, 3, 4, 5, 6. So that would be at 10, 6. This ordered pair is at 1, 2, 3, 4, 5, 6, 7. So that's at negative 7. At 1, 2, 3, 4. Well, it's the open circle, closed circle thing. If it's an open circle, you have to use parentheses. If it's a solid circle, you have to use brackets. So you could almost, when you find the points on the graph, and back here when they had this one, if they had an open circle here, I think they're kind of assuming this is an open circle because they didn't really put a point here. So that one, you just assume that it's kind of an open circle there. For this one, if you've got an open circle here and a closed circle here, even though that's the ordered pair, if it's a solid circle, I would think about that one like this. So open circle means you're using parentheses. If it's a solid circle, you're using square brackets, actually. Oh, solid circle would be brackets. Open circle would be parentheses. Okay, so for this one, if we go domain, where we're going left to right, your left-hand point is here. The x value is negative 7. It's got a bracket on it, so we'll go negative 7. The right-hand point is here. The x value is 10. And it's an open circle, so we need parentheses. And that was the main thing I was going to check, was if they use the square brackets or not. And again, Alex is down, so I can't go back and check it now. That was one thing I forgot to do. If one's an open circle and one's a solid circle. Kind of like that problem last time we were doing the vertical line test. If it was an open circle, you didn't touch it. If it was a solid circle, then you did. And this one's kind of the same thing. That you're going to have to use parentheses. Yeah. Mm-hmm. Okay, and then range, you're going high to low. The low point is here, and that's the negative 4. The high point is here, and that y value was at 6. Okay, so that's the part they'll do. And again, the biggest thing on that one is just to realize when you talk about domain, that one you find the left-hand point and you find the right-hand point and tell me those two values that's in the x values. And when you do the range, you tell me the high point and the low point, and then you tell me what the y values are. So domain, you're always looking left and right. Range, you're always looking up and down. So the domains, you should talk about the x values of that order pair. The range, you always talk about the y values of the order pairs. Sure. Okay, and then last couple of things here. Once they've gone through, and the domain range just kind of pops up out of nowhere because we've gone through plugging in numbers, and where they kind of bring that in is that they're still going to have you evaluate some numbers, but they won't show you that one because the next thing they're going to do is, for example, would this be? I don't know if that was 5. This would be example 6. Yeah. That would be example 7. So this would be 8. And this is where they're going to ask you to evaluate a function. Type 1. I think this was evaluate a rational function. No check, make sure. Yes, evaluate a rational function type 1. And again, rational just means it's a fraction function. Okay, and when you evaluate the functions, the rational functions, Top 1, it's going to be a little easier. Top 2, they're going to make it a little bit tougher when you plug in the numbers. Just means you're going to have to do a little bit more work to get through them there. Okay, so they'll give you just one number to plug in. They're going to ask you to find f of negative 1, or some other number. In this case, we'll pick negative 1. And again, all that means is when you do that, everywhere you have an x over here, you've got to take out the x and plug in negative 1 in its place. Take out that x, plug in a negative 1. This one we're going minus 7 on the top, and then we're going plus 12 on the bottom. And with those two parts where you've got the numerator and denominator, they're basically two separate problems. So you work out the top part. Negative 1 minus 7 is negative 8. Negative 1 plus 12 is 11. If you can simplify that problem, simplify it, but for that particular one, 8 and 11 won't simplify, so that's it. This video. Back up here for this one right here, because that point would actually touch that line, and that's where I want to double check on homework to make sure. When you use this point, because you actually touch that point right here, these two numbers would actually need to be used with a bracket instead. Yeah, so they're assuming that if that's a low point, you're actually going to hit that, so that would be a solid circle. So back here, this negative 4 should have been with a square bracket. So I've got to remember after this time to just do a new video. Okay, so there's one where they give you the type 1. Here's one, for example, 9. This is where they're still going to ask you to evaluate a rational function. This one is going to be a type 2. And type 2 just means it's a little bit longer, a little bit more complicated function. Okay, so still a fraction, still a rational problem. Just now it's a little bit bigger because the other one was just x plus and x minus. This one now we've got x squared. We've got a whole lot more terms on this thing. Okay, so everywhere you have x, you're going to take out the x and you're going to plug in negative 8. So for this one, if we do f of negative 8, that's going to equal negative 8 squared, 4 times negative 8 over negative 8 squared. So plugging in the negative 8 for x's, we need to square this one. 4 times this one minus 45. This one was squared and then minus 49. Okay, and again, the f of negative 8 is just letting us know that we're taking out the x and plugging negative 8 in and working it out. So really, we're putting the negative 8 here for all the x's, and then we're going to work it out. And again, it's a two-part question. You're going to work the top part, and then you're going to work the bottom part. And I'm right at the bottom of the page, so I won't put that over here. So if we do negative 8 squared, that is 64. 4 times negative 8 is negative 32. And then we've got the minus 45. On the bottom, negative 8 squared is 64 minus 49. So bottom part, that's a 15. Top part, that is 32 minus 45, which is a negative 13. And again, that won't simplify. So for f of negative 8, that would be the final answer that we're looking for. Okay, so it's still the evaluating that we did in the earlier parts where you just take the numbers and plug them back in. This time it's just fractions where you have a numerator and denominator. Okay, now here's where they kind of tie in with the whole part that we had with the domain and range. The one thing they're going to ask you to do is they're going to ask you to, what number was this one? That was 8. Oh, this was actually would have been 9 right here. Sorry. Should have been example 9. So this would make this one 10. Got to be better with my numbers. This one they're going to ask you to list the excluded values. And again, directions, it says it's domain of a rational function and excluded values. Biggest thing on this one is when you talk about the excluded values, that is your denominator equal to 0. So it doesn't really worry about the numerator. In this case, you're worried about just the denominator. And same thing, they're going to give you a rational function. And no matter what they do, if they ask you just for the list of excluded values, you just take this denominator and set it equal to 0. Okay, now, and because it's x squared, that means you're going to have to factor this thing. So you're looking for the factors of positive 9, where the sum is going to equal negative 10. And again, you only have two choices. It's either 1 and 9 or it's 3 and 3. And the only way you can get 10 was going to have to be the 1 and the 9. You got your x. And since that number's negative, the bigger number has to be negative. When we do a positive divided by negative, that means this is also both going to be negative. Okay, so setting the denominator equal to 0, we factor it off. And again, to get each of the solutions, you're going to have to do x minus 1 equal to 0, and then x minus 9 equal to 0. And for these, just move the number over, so add 1 to both sides. This one you would add 9 to both sides. And I think in the online homework, they'll ask you to list the numbers, and you have to separate them by comma. Order doesn't matter. 1 and 9, 9 and 1. As long as you got the 2, that's all you're looking for. Okay, and then the last thing. So that was 8.2. Here's the one, and there's only one thing in 8.3. They ask you to identify linear equations. All right, and there's really only there's 2 or 3 main things that you're really looking for on this one, and we'll give you those. For it to be linear equations, x and y can only be to the first power. So if they give you one of these equations and you have x squared or you have y squared, it's not linear. So x and y both have to be the first power. Okay, second thing. And this is more of a cannot have. You cannot have x times y. And then the third thing you're looking for is you cannot have x or y in the denominator. So really, instead of it being what it is, it's more of what it's not. That if you're talking about what makes something out to be linear, you can almost say it's three things it cannot be. It cannot have x to the second power or bigger, or y to the second power or bigger. You cannot have x times y, and you cannot have x or y in the denominator. If it's not one of those three things, then you're pretty much good to go. And what they're going to do is they're going to give you a box like they do all the time, where here are 4 equations. It doesn't need to be that big. And then out beside it, they're going to give you a yes or no bracket. That's way too big. No, that's strictly yes or no. There's nothing you do other than you look at it. Okay, so you've got x to the third minus 3y equals 8. X to the third, right? Power is bigger than 1, so that's a no. Okay, 5x minus 7 plus 3y is equal to y minus 4. X and y, everything's the first power, we're good there. We don't have x times y, so we're good there. And don't have any variables in the denominator, so it's all good. So that one's a yes. Okay, 2 more and then we're done. So 5xy plus 7y equals 4. Right there. Got x times y, right? There you go. So that's a no. Alright, and the last one. Okay, now you've got 5 and 3 denominator, but it has to be the variable, so nothing's there. X to the first power, y to the first power, they're not multiplied together. There you go, good to go. That's a yes.